Dear children, the topic is limitations of Rutherford's atomic model. If the electron moves in a circular path, they have a centripetal acceleration. According to electromagnetic theory, if a charged particle accelerates, then it must radiate energy. This loss of energy would slow down the speed of electron. It loses their energy continuously by radiation. So when the speed of electron decreases, then the electron will attract towards the nucleus, which is oppositely charged, and it follows a spiral path, and finally it should collapse into the nucleus. So the atom does not stable. So the Rutherford cannot explain the stability of atom. This is the first drawback of Rutherford's model of atom. The major drawback of Rutherford model of atom is he did not say anything about the arrangement of electrons in the orbit. Dear children, the next question is, using Rutherford model of atom, find the or derive the expression for the total energy of electron in hydrogen atom. You know that electrons are revolving around the nucleus in circular path. To keep the electrons stable in their orbit, the electrostatic force of attraction between electron and the nucleus provides the centripetal force. You know that every object revolving around the circular orbit exerts a centripetal force towards the center. Here, the electron having mass m and velocity v revolving around the circular orbit having a radius r has a centripetal force denoted as Fc equal to mv square by r. The electrostatic force of attraction between electron and the nucleus is denoted as Fe, that is equal to 1 by 4 pi epsilon 0 into magnitude of the charges. Both have the charges E with the opposite signs. So, E square by R square. To keep the electrons in the stable orbit in a hydrogen atom, this centripetal force is equal to or must be equal to the electrostatic force of attraction between electron and the nucleus. So, we can equate these two forces, that is Fc equal to Fe. From this equation, we want to find out the total energy of electron. So, we can write for the Fc. What is Fc? mv square divided by r. That is equal to Fe, that is 1 by 4 pi epsilon 0 E square by r square. Note it as equation number 1. Then we can cancel this r and r square. Then we can write the radius of the orbit of hydrogen atom, that is r equal to 1 by 4 pi epsilon 0 E square by m v square, equation number 2. So, this is the relation between orbital radius and velocity of electron in the hydrogen atom. From this equation, again we can write the v square. So, v square equal to 1 by 4 pi epsilon 0 E square divided by m r, equation number 3. When the electron is revolving around the nucleus, it has a kinetic energy and it attains a distance r from the center of the nucleus. It has a potential energy, that is electrostatic potential energy, because they are the charged particles. So, we can write the kinetic energy equation. Kinetic energy is denoted as K, that is equal to half m v square. What is the v square? That is from the equation 3. V square is 1 by 4 pi epsilon 0 E square divided by mr. So m and m we can cancel. Then kinetic energy equal to 4 into 2, 8. That is E square divided by 8 pi epsilon 0 r. So this is equation number 4. Then we can write the equation for the expression for the electrostatic potential energy U. So you already studied in the second chapter, that is electrostatic potential energy U equal to minus E square divided by 4 pi epsilon 0 r. Equation number 5. From this 4 and 5 we can write the equation for the total energy of electron in the hydrogen atom. So what is the total energy of electron when it revolves around a circular path? That is total energy equal to, so we can write total energy T equal to kinetic energy plus potential energy. So what is the kinetic energy? So kinetic energy is E square by 8 pi epsilon 0 r. Potential energy minus E square by 4 pi epsilon 0 r. So we can substitute these two values. That is E square divided by 8 pi epsilon 0 r plus what is the electrostatic potential energy? That is minus E square by 4 pi epsilon 0 r. Then after simplifying the equation we can write one more step also here, that is E square divided by 8 pi epsilon 0 r minus E square divided by 4 pi epsilon 0 r. After simplifying all these equations we get the total energy of electron in the hydrogen atom. So it is also represented by E, total energy T, or we can represent the total energy E equal to, okay, that is equal to, after simplifying we get minus E square divided by 8 pi epsilon 0 r. So this is the total energy of electron in the hydrogen atom according to Rutherford model. So here this negative sign represents that electron is bound to the nucleus, that is electron is close to the nucleus. If this value, that is if E is positive, then electron will not follow a closed path in the orbit around the nucleus. Thank you.